Thank you for having me here. And I'm going to try and get things to be an interactive session. So we'll see. And I've been working on this idea for a long time, and I need some help. And you guys seem like a perfect audience to help me out and maybe point out what's wrong with this. But let me tell you about something I discovered recently in working on RPC and web services and database access, clients accessing to databases. And this is an old problem, and it's very frustrating because when you have an old problem, it's like, well, RPC sucks, Corba sucks, RMI sucks, web services suck, everything's crap. Well, let's just give up and do async, It'll solve everything, right? And it's like I'm working on a problem that's dead. We've given up on this. And let me tell you here's what we're doing, what we've been doing. Oh, actually, before we do that, quick about me. Research. I was actually a software developer for 10 years, and now I'm back doing research. So I'm kind of foot in both worlds. But what I really want to talk about is this issue of how we go about adding distribution capabilities. And databases I would put in there as well, because they also have a notion of remoteness in some sense. The data is over there. What we typically do is we design the programming language, and then we finalize the spec, we write the compiler, we ship it, and then somebody says, oh, we need a distributed version of this. And so we then implement stub compilers and generators and libraries and all this other stuff. And then the inevitable third step is that everyone yells at you and says, that's crap. And it's largely ignored by the community. I think that this whole idea is one of the great programming language disasters of the last 40 years. We just keep doing the same thing over and over again, and it's wrong. The people don't want it. We can give it away, and they don't want it. And what are we doing wrong? It's interesting. I love that definition of insanity, right, where you keep doing the same thing over and over again, and you expect different results. Well, that's what we're doing. And it's because we don't have any better idea of how to do it. Another interesting note is that this building, the Agnews Development Center, was originally built as an insane asylum. And so now you can, it's fitting that we're talking about this, and you can say that you've been in, what's that? Yeah, we're all insane. And I'm also a serious addict. So it's nice that when society is willing to pay me a lot of money for my addiction to programming. But anyway, so let's go back and just, I'm going to use this example over and over again. And this is like the LS program or a mail listing program, getting a client. We want to iterate over a bunch of messages, maybe find some big ones, print them out, and we're actually cleaning up the folder. We're deleting old messages. I don't know. There's a lot of examples of cases where you iterate over some collection, you test for things of interest, and then you do something to them. Now, one thing about this code is that it involves this mail or mailer API, but it also involves some local computation, some non-mail API, like the print function, which I haven't specified. It's just some print function. But this works great if the mail object is in memory in the same place where the print function is. But if you do the RMI Corba thing and you try and move the mailer here to say, oh, that's a remote object. That lives somewhere else. We have a proxy to it. And so every time we send a message to it, sorry, we're talking about messages at 2 levels, but every time we invoke a method, it has to go over to that real object, come back with the answer, and everybody can see that this is going to send a lot of network traffic, right? It's going to go back and forth to get the subject, the name, and the size, and all that stuff. And the actual network traffic is proportional to the number of messages that are in the database, not the number of messages that are going to be deleted and printed out, because it has to go and get all those messages, even the ones that the client doesn't care about. The other thing that's interesting is that asynchrony, you could try doing this asynchronously, but that's not really going to help because you need to check the size before you can, at least in the normal execution order, check the size before you know whether to go and delete the thing. So there's limits on sort of asynchronous behavior. You could try and rewrite this completely to expose the more underlying parallelism. But what I'm going to do is just say, well, why can't we run this code and have messages be remote and have everything that we want? Okay, we want it to be fast, so we want just one round trip to the server. That's the puzzle. We want no proxies, because proxies are, they contradict statelessness, right? They require the server to maintain per connection state for all clients. And they have an unbounded lifetime, and they have distributed garbage collection and all this stuff. How many people have worked on a distributed object system library? Oh boy, a lot of insane people here. It's amazing. Anyway, so here. How many people still do? Yeah, well, okay. I didn't get a lot of disagreement when I said it's crap. You know, it just doesn't work, right? It doesn't work very well. So we also really would like it to be platform independent. So this idea of serializing the internals of an object just doesn't fly. How do you take a Python hash map and serialize the guts of it so that it can be loaded into another machine? And then we've got these workarounds called data transfer objects and server facades, which let us write servers that actually work using this approach, but it requires us to design our server interfaces based on the client usage patterns. So if the client usage patterns change, the server has to be rewritten. That's backwards. We've got the tail wagging the dog. And then also there's some technical issues like having to change your classes to put a special superclass like remote, which is messy. So yeah, let's fix this. It's a really simple idea. There's a bunch of remote operations going on here. They're in blue now. Everything that touches, every object that came from the mailer. Okay, so we get the messages out, we check this, we get the subject, the sender, we do a delete. Those are the things that have to happen to server objects. And the black stuff, well, like this print here at least, has to happen locally on the client. So you can't do the other thing that people often say is, oh, just do mobile code. Send the closure over. Well, there's mixed local and remote code in here. So you can't just package it up and send it to the other place. Although we're going to do that in a minute. So how many people have read my papers, or how many people who haven't read my papers know the answer to this problem? We want to do this in one round trip. With no proxies, no serialization. Anybody get it? No? Let me give you a simpler example. Here's the code. We want to call two methods and print out the answers. Print r.foo, and r is remote. How do we run that with one round trip? You batch your request. Yeah, well, I already gave you a hint. You batch them, right? So if you could take these parts here and lift them out, okay, the server could run that directly, right? We have this idea of taking a single call and lifting it out and sending it to the server. Why can't we take a pair of calls and lift it out and send it to the server? Okay, and then when we've lifted this out, what's going on now is that we need a new intermediate data structure. We need this to go into a little pair with an A result and a B result. And then we just tell this thing to say, get A and get B on the client. So if you could transfer the results of running these two methods, and then put those results back in there, then you'd get a single round trip. So that is pretty clear. You can do that for two statements. But what I'm saying is that you could do that for loops too. We could just run all the blue stuff first. And then everywhere that it needs an answer on the client, collect up those values, bring them back to the client, and then run the code again. Run the black code. So you could bring back the Boolean. If the client needs to know the Boolean, then you bring that Boolean back from the server.
When limit is on this side.
What's that?
If limit is on the client side.
Oh, well, let's send that. When we go and ask the server.
But if limit depends on, say, a result of a print.
Yeah. So if limit, if you had a tangle of that it required. So the issue is that a lot of times you need to do a bunch of operations and then get some answers back. And that's a very natural thing, that you collect up some local information, send to the server, have it do a bunch of operations that depend on that input, then get the answer back, and then process the results. Now, if for example, you wanted to ask the user, do you want to delete this? Then that would require on the client to print out the name and the subject of the message, and then get an input, and then send that to the server. That would not be able to be untangled and separated in this way. Okay, so there's some constraints on what you can do in this model, but we know that this model works because that's what SQL does. You send a request to the server, it does a bunch of work, you process the results. Okay, yes, so I'm going to go into those details, but here's the whole thing in one slide. The programmer writes this code, and we actually introduce a new control structure called batch that says everything in this block is guaranteed and required to be done in one round trip to the remote server, whatever that remote server is. And it identifies what the root of that sort of service is. We're going to talk to this mailer object. We're going to do a bunch of operations on it. And what happens is that here's all the blue code pulled out into what I'm calling batch script. Okay, it's a little programming language whose purpose is to send collections of interesting operations to a server, have them get executed, and then collect up the answers. So B and C, these out B and out C, are marking which results from the server need to be brought back to the client. And then this is all the code that's left over. There's still a for loop here, but it iterates over the results that were brought back. It doesn't iterate over the actual server collection. It iterates over an intermediate data structure that represents, it's like a table of partial results. And then it prints those out. And notice that the if statement is gone from here, because you can actually tell that the client doesn't need any information about messages that are not that were not deleted and need to be printed. So the server doesn't even need to send back the extra information, and because the server doesn't need to send it back, the client doesn't even need to test for it. So that's the basic idea, yeah.
So if you're sending code over, how do you get security so you know that the code you're running is not being forged to do something malicious?
Yeah, so what you do is you restrict the language that you can express in the code. This isn't Java bytecode. It's a very restrictive language that can only call methods, evaluate conditions, and do simple loops.
But you can still do delete, so it's no security.
No, that's a server method.
Okay.
The server is providing the delete operation in the public interface. Okay, so it's the same capabilities that you could do with RMI. If the server doesn't want to expose the delete method, then there's no way for the client to get at it. It could also pre-process this and do security checks on it because it's a very simple scripting language.
So what's to prevent someone from forging an attack where they give you an infinite loop?
You can't write infinite loops in this language. There's no while wait statement. But it would be good for any server to control its resource consumption. And there are ways that a script could do sort of a denial of service type thing. Now, the other thing is that I'm not necessarily, you could actually give this as a kind of a public web service interface. And we've reprogrammed the Amazon Web Services to use this style. And what it does is it actually, this code should look very familiar. This is the JDBC batch, command execution pattern. And what I'm saying is that no one should ever write that. You should never write .execute as a programmer. You're doing an anti-pattern whenever you do that. Because you should have written this, and the compiler generates that code for you by splitting the stuff in two. Okay? This is explicit metaprogramming here. We actually have to manage a script object directly and build it. Whereas this, there's no metaprogramming. It's a lot like partial evaluation, if anybody knows that, or staging. We're separating it into two stages. It's a lot like very aggressive compiler optimizations that do out-of-order execution. So one other big constraint is that we're reordering the semantics of this code, so that I said that all of this stuff happens first on the server, and then we run all this code. What that means is that all of the files will be deleted before a single print message occurs. So is that valid? Well, what about side effects? What if delete somehow has a side effect on the print stream here? You're going to get a different behavior. So the argument here, the assumption and the requirement is that the effects that occur remotely are disjoint from the effects that occur locally. And that's typically true of a remote system. And so it's legal to reorder those effects with respect to each other. Yeah.
So can you have transactionality on top of this too?
You could. You can. Yeah. This is being submitted to the server, so you could have a transactional RPC server. Okay. Please do these commands and do them atomically. Right. There's no reason to restrict that to just SQL type operations. Oh, and by the way, I didn't mention this thing. This little table. This is that intermediate data structure that gets sent back. What happens is that there's a labeled item is created for each of these outputs, B and C. For every loop, it makes a table. And if there are 3 or 4 nested loops, you'll get nested tables. So this is more powerful than the flat relational model. It's a hierarchical.
If I want to key my transaction to a final action in the client, is that a tangle in your model that can't be done, or is there a way to get a second phase?
In the simple version of the model right now, it's one phase. However, there is this connection object, okay, is the thing that there's a pluggability capability here. That what actually happens in the compiler is that the partitioning happens automatically. It creates this script, but then it just hands the script to the execution connection. And that execution connection can choose to do 2-phase commits and things if it wants to. Yeah. And that's very easy, much easier to write a plug than, say, a link provider, for example. Yes?
I've done this.
Excellent.
I didn't know that those words that you're saying would apply to what I've done. So I can give you interaction, but not now. I mean, after you talk.
Okay, great. Yeah, no, it's startling that we haven't discovered this before, but I actually assume multiple people have discovered it. But it's never been published. And you're the first person who's ever said, oh, I've done this before.
Because the room, forgive me, because I'm going to use the word monad in a sentence.
Yeah.
It's like you've taken Pascal's I/O monad and applied it to the code and not the side effects, which is cool.
Yeah, there is a kind of monadic interpretation here, absolutely. Good. Okay, so it's very simple. It's a new pattern. It's a meta pattern, sort of. Well, all patterns are meta at some level. Basically, the idea is that we send scripts to the server, we execute the script, and then you get bulk results. And the key thing is that you don't write that explicitly. The compiler does it for you. And by the way, this batch script, which I'll show you the scripting language in a second, here's a little snippet of it that we were looking at. This is can also be translated into SQL. Okay, so there's a pretty tight correspondence between certain kinds of batch scripts which are written against certain kinds of interfaces. So the other variable here is, what does the server interface look like? If the set of operations that are provided by the server look like a database, then you can convert scripts into database queries very efficiently. And in particular, it actually guarantees a constant number of queries, so you never ever get the n+1 query problem. Any batch is always a finite constant number of queries, no matter how many nested loops there are, while loops or anything, or for loops. So that's a nice property. And that's not true of link as well. So here's the scripting language. In case you haven't noticed, it's actually a subset of JavaScript, syntactically. So this is like the flip side of JSON. That was JavaScript for data. This is a subset of JavaScript for code, okay, for talking to your server. And it lets you access fields, call methods, do assignments, have primitive operations, conditionals, loops over a collection, not unbounded loops, local variables, output and input, and lambdas. There's a few cases where we need first-class functions for doing aggregation-style operations.
So if you have first-class functions, can't you have infinite loops that way?
You can't actually call them from script. It's odd. You can't call them. You can only hand them to server routines that can then call them. So, yes. The other thing, you can't do a lot of things. You cannot call constructors. You can't call static methods. You can't handle exceptions, although exceptions can occur, and we can talk about how they work. But the point is, it's very restrictive to basically a pure model of OO programming. All you can do is talk to things that are in the server interface, and then do a little bit of sort of conditional logic around that. And, oh, the other thing I didn't mention, which I really should mention, is that the only data that goes back and forth between the server and the client, there are two things that move. One is the script, and that has standard. There's got to be a global standard that says all servers are going to agree on this batch script, just like we all agree on JSON. It's very simple. You can write a interpreter for this language in 800 lines of Java. That's pretty much complete interpreter. Okay, it's a very simple language. It's like, CS easy. The other thing that moves is these data blocks, which are, I call them forests or result trees. And these are just hierarchical collections of labeled primitive values. Dates, strings, numbers, that's it.
Have you looked at, so Redis actually supports this model.
What does?
Redis?
I don't know it.
Okay, so Redis, it's now probably, second to Memcache is probably the most popular data structure as a service.
Okay.
Essentially. And, last year they added Lua support
Okay.
to the server.
But the issue is really this, it's the partitioning, it's the client side that's nice.
I mean, the rest of the model, though.
The rest of the model is very well known. Yes, exactly. And yeah, I mean, it's based sort of traditionally on SQL. But the point is that there's no serialization of objects. There's no primitive data. No objects move across the wire. Only these collections of primitive values. So you can do this between Python and Java and C and Lua. There's no problem because everybody can agree on the basic data types. And we don't have to agree on anything else except basic data types, script format. Okay, so anyway, I mentioned that you can write these little batch providers, these plug-in things. So one of them is a batch. What it does is it just executes the script. You can also convert it to SQL and run it against the database and get the results back and decode the results. It's like a front end for a SQL engine, execution engine. And you can also plug in a little remotable pair where there's a provider that doesn't actually execute the scripts. It just takes them and hands them off to someone else, where we need a receiver that can do that. And it then has a plug that says, how do you want to execute it once I send it to the server? So they're like little Lego blocks. And then we combine these. Oh yeah, so as I said, 568 lines of code to write an interpreter. You can use any kind of transport you want. We need to get away from fetishizing the transport. It doesn't really matter. But if you plug, this is a configuration where we've plugged the execute engine into the remote side, and this is an RPC server. And then if we plug in the SQL generator into the remote, we get a sort of a two-tier SQL execution engine, if you want. And separating the issue of execution from remoteness a little bit. Okay, so you got to change your programming language. That's the insanity. The insanity was we can build a programming language that doesn't do remoteness, and then we can add remoteness later. It cannot be done. You can't do it. You need to change the semantics of the language. You need to add this batch thing to let it partition the code to handle remoteness. But you can do that in any language, but that's work. I'm proposing a language change, and people don't like that. So I'm pretty convinced that there's no alternative if we really want to solve this. The server, you just need a little, this is really easy to write. You just write a little execution engine. It's a little bit like a standard, it's even easier than a Corba server because you don't have to do proxies or marshalling or any of that crap. I mean, it's just dead easy. Stateless, no remote pointers. And the other key point I didn't mention, in terms of the interface between the client and the server, it's okay to use fine-grained interfaces. It's okay to have lots of little methods and lots of little properties. Just go crazy. They're all fast. They're all free. It doesn't matter how many of them you call. It's all going to be in one batch. So you get your server facades for free on the fly. So we don't need to go crazy rewriting our servers all the time to have these bulk interfaces. And the only thing that communicates back and forth is data blocks. Yeah.
In your loop, you can call local methods.
You can call server. See, that's the thing, is that it looks like a local method, but it's actually, the code runs on the server.
Yeah, but if you have an if that takes
Yeah, okay.
methods.
Yeah, so I mean, this is the tangling issue. So I was talking about that a batch has to be one round trip, and you get a compiler error if it's not. So if you try and get something from the server and then ask the user and then do something else on the server, that requires 2 round trips. And so that's a static syntax error. Yeah.
So if you take the print example, say that get a, for example, returns an object. And say you're in Java, for example,
Yeah.
where in order to print something, you have to turn it into a string.
Yes.
So print has to call to string or whatever it
On the server.
Yeah, but so do you have to do whole program transformation in order to find that out?
It's a whole program transformation of the batch block.
Yeah, but you can't really restrict the batch block, right?
Yes, it has a scope.
Okay, so
It ha-
how does it find out what goes on inside of the print method?
Okay, so that's the thing, is that yes, the print method cannot, well, I'm going to talk about this in a second, but the default assumption is that any local operation has to run locally, and all of its inputs have to be primitive data. You can't call print and have it take a remote object as an input. That's a syntax error as well, because it can't take that print and split it into two parts and run part of it on the server and part of it on the client. So the issue is that get has to return something printable.
Yeah, but objects
Like a string.
are printable in Java, for example.
What's that?
Objects are printable.
Well, yeah, but that's only because it inserts a toString. But the point is that at this point, it can know, so print has to take a string or some primitive data, is what I'm saying. And so the toString will happen on the server, and it'll know that based on the fact that print is local, it requires data. Foo returns something on the server, and I think I actually have some more slides on that. So what if you do want to move an object from the client to the server? That's kind of what you're touching on. Let me do this quickly. So let's say that we want to send, we have a set of strings, which is the local IDs, okay? And we want to send that to the server. That's a local hash set, so that can't jump to the server, is what I'm saying. So what you want to do instead is use a factory on the server to create the set, and then populate it by iterating over the local data and writing it into the server set. So that's going to basically serialize the set, but doing it through its public interfaces, not through the private representation. Okay, so this works just fine. We make a server set, we iterate locally, and then what will actually end up happening when it partitions this code is it will collect up all the local addresses first, send them to the server, then run the loop that will populate the server set, and then it'll do the operation. So there's no tangling in that. But the issue is you don't want to have to write this code over and over again here. This is like a copying code to copy from a local set to a remote set. We want to reuse that. And so what we do is we need to be able to modularize procedures that aren't considered local code or pure remote code, but are hybrid. They actually have some local and remote in them. So basically I mark the procedure itself as a batch method, and what happens is that it gets two versions of it compiled. One is the normal straight line version, and another version is a batchable version of that procedure that can interact with the batch block. So what that does is essentially it inlines it. It inlines it into the batch block if you call a batch procedure. And that this is the code that needs to get inlined, and it does the copying, and this is the issue you're talking about, the whole program analysis. When you start from a batch block, everything that it calls locally is just treated as a pure black box function that can only take primitive inputs, unless it's been marked this way, and then it gets inlined into the batch.
Can you show us the version of that hook for string?
For string,
Yeah.
strings get moved automatically.
Oh, so there's special cases.
Yeah, all primitive data, strings, dates, integers, floats, things like that. What we choose to be considered primitive gets special support, yeah. Okay, and then we can just call that thing, and this is a local procedure, which normally I would say, ooh, that has to get, it has to exist in one place or the other, but because it's been marked as a batch procedure, it can live in both. Exceptions are interesting. The server can actually choose what to do with exceptions at some level. It could abort the entire block and restore, and do a transactional model. The kind of default RPC model that I have is that it runs the batch, it runs the script on the server, and if an exception occurs, it terminates that and brings the exception back to the client. Now remember, the client is going to rerun the same control flow, and so at the point when it would have called the server method, it will raise that same exception. Okay, but you have to be careful because you can actually get into situations where, that situation is actually pretty good. If the server gets an exception, the client will raise the same exception in the same place.
How does it handle stack traces? Does it show the server or?
That is up to the server to decide what to reveal. It can,
And exceptions has to be treated as primitive too?
yes. Yeah, there's a,
You can't put arbitrary.
you can't put arbitrary stuff in there. There's just a simple exception model where it can capture something and bring that down to the client. But there is an issue with, we have to have some kind of standard for how to treat exceptions that has to be agreed upon. That's an area that I haven't actually fleshed out enough. The worst case is if the server runs to completion, and then while the client is processing the results, it gets an exception. It can't print out something, because that's a case where the server work has already been done, but the client isn't really sort of processing the results of that work completely. So clients do need to be careful about their exceptions. So we mentioned transactions. It doesn't solve the problem of partial failure, but it certainly reduces the number of intermediate stages where partial failures can occur. They can be transactional. And then there is an issue of effect analysis that we need for this to work. So here's an example of the print case. But here it's making it explicit the fact that it's doing it's passing a local parameter to a server routine and then printing the result locally. Then it does the same thing again. A local parameter that's computed, passed to the remote, and then printed. And in order to execute this in one batch, the only way to do it is to get the two inputs first, then send it to the server as a value, which can then run the two updates, and then get the results back and print those. And so here's an example of that. So it's going to call get A, get B, and then print. The problem is that we've reordered the local code. It's supposed to do get A, print, get B, print. And those are both local code, so they are allowed to have effects that interact. And so reordering it is invalid. And the system has a simple effect analysis that basically gives you the syntax error and says, sorry, this batch can't be executed in one round trip. And that is a little tricky because it's hard to tell in general whether a Java method will have an effect or not. Yes?
So can you declare that?
In the current version of the code, no, you can't. But there ought to be a way to declare that this is, print and get A are side effect free, or at least non-interfering. Yeah, so that's an issue that I'm still working on. Okay, and then we do use lambdas sometimes, by the way. We try and avoid them. If you know link, this gets rid of a lot of the link stuff and solves some of the problems with link where you're making this anonymous intermediate data structure. The current code that I'm running isn't based on the new lambda stuff, so I've hacked it into the old, kind of existing Java by using a function object. But it does allow you to, what happens here is that this function object gets marked as a batch procedure, as I said, and a version of it that is remotable gets compiled. So we're talking about kind of remotable code. All it's doing is getting the category, and that'll get sent as a lambda in the script to the group by method. So this is the case where we need to send little bits of code. All right, so anyway, so I actually have a prototype originally done in Jastad, but I got motivated to convert it to Java-C in the OpenJDK. And I'm happy to announce today that I have an alpha release of that available, so you can just drop in and get your own Java-C with batches. And it's basically compatible syntactically from a syntax and type semantics. It's completely compatible with all previous versions of Java because it's just an optimization. It doesn't actually change the sort of logical semantics of the language at all. It's just a really neat optimization. And it's really easy to write these batch plugins. I've been hoping to get somebody to do one for a coprocessor. Consider it remote, and you can send it a batch of operations for that case. There's a lot of uses for this. It also includes a fairly complete SQL generator. One of the odd things about it is that even though it looks like an ORM and works like an ORM and better than a lot of ORMs in some ways, it never actually instantiates the objects on the client. It just goes and gets all the primitive data that you need. So if you think about it, the objects never move from well, they wouldn't exist on the server, but there's no logical object that's instantiated on the client. It just uses the results that come out of it, and we could probably add a more robust ORM if you really want to get the objects themselves. I can show you a little bit of an example here. I was just playing with this. So if people are familiar with LINQ, LINQ has a bunch of examples, and here's just one little one that LINQ says, make a query and get these products, and then find the ones that have a certain price, and then select it, and then do the loop over that, and then process the results. And if you see that, that's the batch execution pattern again, because we're executing a query and then we're processing the results. In the batch version, we just iterate over the products, test the condition, and print out the answer. So it's a little more procedural. The queries are implicit in the if statements. Some people think, oh, but queries are good. We got to have queries. Well, I don't know about that. Sometimes they're good, but other times they just, they're kind of an artifact of trying to do this batch execution model. The thing that really gets ugly is when the projection, when you start having to have custom results in LINQ, what they do is like this. What's going on here is that it's selecting some products, but then it's going and getting some arbitrary data associated with that product. The product, the category, and a Boolean of whether the price is equal to the unit price, and the unit price. Okay? And so what's going on is we're kind of creating this new synthetic object that has no real purpose other than to transfer the data from the query to the place where it gets consumed. And again, in the batch version, all those synthetic objects that are about plumbing of moving data from the server to the client just happen automatically. It's a little bit like, lately I've been thinking of like chromosomal separation, right? We take the blue code and separate it out, and they're little strings that go back, to the client to where the data needs to get plugged in. But so for some of these use cases, it's actually much cleaner and simpler than LINQ. Okay, so we're going to have a workshop this afternoon. I am out of time. I'm very interested in hearing your input and getting more feedback and getting help on this, because I've been doing this with myself and a few grad students, and I would love to have everybody help out.